Okay, uh, we're doing another example of Newton's second law. So they've given us a statement here. It says that two boxes A and B, they are lying on a table, as you can see in the picture, and they are connected by a piece of string. Whenever we see string, most of the time we know that we have tension. And then the mass of box A, is 3 kg, and then mass of B is 2 kg. So here we are writing important information, and we assume that the mass of the string is very small, so we can ignore it. And then there's a 30 Newton force pulling the whole system to the right, causing the two boxes to move. The surface acts with a frictional force of 5.9. So frictional force at A is equals to 5.9 newtons, and frictional force at B equals to 4.1 newtons. So we are asked to calculate the acceleration of box A and box B. We know that in Newton's questions we have to draw a free body diagram. So if you look at for A, you know that we have a frictional force, we have a normal force, and we have force of tension, which you can see here that is going to the right, and we have a gravitational force. This is for A. And for B, we have an applied force that is pulling the system to the right. We have a normal force, we have a tension force, as you can see here, and we also have a frictional force. There is a frictional force here, which is this one that we're given, and then there's a gravitational force. So if you look at our problem in this case, we are going to ignore the vertical motion, because there's no vertical motion in fact happening here. So we're gonna ignore normal force and gravitational force, since they cancel each other out. So we write the equation for block A, F net equals to MA. We look at this free body diagram. We look at the forces, so we just decide which one we are taking as positive and which one is negative. So I prefer taking right as positive. So Ft minus frictional force of A is equals to MA. Now I can substitute what I know. Ft we don't know, minus frictional force of A is this one, minus 5.9 equals to mass of A is 3. So you have the first equation. And for block B, the same equation of F net equals to MA. And we have applied force minus force of tension minus force of friction at B equals to MA. So we also substitute to find FA we were given is 30 minus tension force minus this one we're also given, which is 4.1 equals to 2A. This is our equation 2. So we are looking for acceleration. So both these equations have two unknowns, so we can solve them simultaneously. I prefer using the substitution method. So we can just add the two equations, equation 1 plus equation 2. So 30 minus 4.1 plus minus 5.9, so it's equals to 30 minus, this is equals to 20. So ft plus ft equals to 0, which is equals to 3a plus 2a, it's 5a. So divide both sides by 5. A is equals to 4 meter per second squared to the right.